Hi, I'm Sophia. This is a video on logarithms and exponents. If you need to take notes, please pause. I hope you enjoy the video. The base of the logarithm is usually 10 when it isn't specified, but when asked, you can always plug it in into your calculator. Logarithms are basically exponents but reversed to see how many multiples of a number is needed. When raised to a power, it means the base number is multiplied by itself that many amount of times. There are a few logarithm laws to follow, and I will explain how and when to use this later in the video. As you can see, the exponent laws are very similar to the logarithm laws. In fact, they complement each other as inverse functions. This is an example of the inverse function. This is how the values can be changed to find other variables, like how 4 and y are changed. The bottom shows the path of the log law, the x is the base, while the b is the exponent, the c is the result. This can be used to change logs into exponential form. Here is how you write the equation in an inverse function. Using this, we can find numbers and variables through either exponential forms or logarithmic forms. It just depends on what numbers are given, and you can choose either to plug it into a log form or exponential form. For example, when given a power of a number, we can solve it using log by putting it into the inverse function where the equation can be solved. The result is then 5.492, which can be plugged back into the original 2 to the power of x equals 45, making it 2 to the power of 5.492, giving you 45. Without log, it would be much harder to solve. Using log function in addition and multiplication when given a number like log 2 equals 0.301 and log 3 equals 0.477, it makes the system easier to solve as you add these two numbers together, giving you the log of 6, which is 0.778. Likewise here, it is the multiplication version. You are given log 16. You break it down to log AB. 16 is 4 to the power of 2, then plugging in 4 and 2 into B and A and solving the equation gives you 1.204. Again, this is the same idea. When given values, you plug it into the equation and you solve for x, or in this case, log. Putting log 3 over 2 into log 3 and log 2 form makes the equation easier to solve as you have values of log 2 and log 3. All you have to do is subtract, giving you 0.17. In this case, it is very similar to the last example. Even the formula is the same, but there is a negative exponent. When this is seen, take the inverse of the number. 1 over 3 becomes 3 to the power of negative 1, and negative log 3 gives you negative 0.477. These two values on the top are given using exponents to solve this problem. Well, again, like log functions, follow the formulas, memorize them. I promise it will help. 6 is the result of 2 times 3. With exponents, you add, so 0.301 plus 0.447, which gives you 0.778. Like the last slide, you use exponents, but when the exponent is outside of the parentheses, you want to multiply instead of add, again seen in the formula. 0.301 times 3 is 0.903. In the other slides, using exponents, when they are multiplied, you add. So when you are dividing, you subtract. It's a good example where exponents and logs are used together. You should know your square roots, it will help, but if not, logs can help out. Set the base to what you want the multiple of, and the exponent as the number you want to see how many multiples there are. The exponent part you can further use like a normal system of equations and solve for x. To wrap it up, here are a few main ideas you should know. Understand that exponents are like logs but flipped. They can aid each other to find missing variables. When the base part of a log is left empty or not mentioned, the base is 10 unless told otherwise. Make sure you understand the wording of problems like the power of 2 means 2 to the power of something. Thank you for watching this video and I hope it helped. Good luck on your test.
Created using Powtoon.